what does absolute value do? I mean, we've graphed the absolute value function. What is absolute value? Makes everything turn positive. In general, it's measuring distance from 0. And distance is always positive. So no matter what you plug in, you get out a positive answer. All right, I want to first look at a graph and then kind of start getting into the solving. So if I gave you this graph and asked you to graph the absolute value, okay, we don't even know the equation from it, but we could get the graph of the absolute value function. What does absolute value do? Makes everything positive. So will this part of my function that's already positive change? No, that's going to stay the same. But anything that was negative will change. So this point was at 1, -3. Where will that go? Okay, I had a point at 0, -2. That would go to 0, 2. This horizontal line is just going to be up here. So if I graph the absolute value, it's this piece. All it's doing is taking anything that was below the axis and flipping it up. Okay, so you don't even have to have the full equation. You can do the absolute value from a graph. Could you tell me the domain and range of each of these? If I wanted my original function. What is the domain of that? What was the range of the original one? Okay. Start at -3 and hit everything above that. When I did my absolute value function, did my domain change? No, because absolute value doesn't change x, it changes y. So domain stayed the same. Range, what's the range of my new function? Starts at 0 and goes to infinity, because absolute value always gives us positives. Okay, so when you do the absolute value, your range will become 0 to infinity. Domain doesn't change. Let's do one more of those. This time I'm not going to give you a graph, I'm going to give you the equation. All right, we were graphing these all last week. I told you to graph x minus 4 squared minus 3. What's my parent function? Square root of parabola. 0 squared is 0. 1 squared is 1. -1 squared is 1. Okay. How would this original one move? My transformation there. So this is my original. Can you guys tell me what the domain of that is? What's the range of that one? Okay, good. Could you have done Like, you might have been able to get a domain and range of that without looking at a graph, and that's also okay. I didn't say you had to graph that one. So if you knew enough about the graph, that's an option. When I say the absolute value, this is probably the only thing that you did not do last year concerning the absolute values. If I ask for the absolute value of this, what part of my graph changes? Then, yeah, that negative part, right? Did the part that was already above the axis change? No. So when I graph it, this is still here. This is still here. But the part that was below my axis will get flipped up. Okay, it's just like a reflection. So it turns into something like this. Can you tell me the domain and range of that? Domain didn't change. But what's my new range? Alright, so if I'm asking you to find the absolute values of those functions, domain never changes, but your range will. When you do the absolute value, it's only talking about positives. Alright, so that's kind of like a visual representation. The main piece that we're looking at today, though, is solving equations and inequalities. So I want to give you guys the rules, and then we're just going to solve problems until we've got it. Okay? So, if we have an absolute value equation, for instance, if I said the absolute value of x equals 3, what can x be? 3 or negative 3, right? So, if you have the absolute value of x equals a number, it could be that x is equal to the number, or x could be the opposite of the number. You want to have these rules written down. So in a few minutes when we start solving these problems, I'm going to ask you, look back at your rules. What does it mean? So if it's an equation, you are getting two answers. You set it equal to the positive and the negative. What those inequalities mean. So number 2, when I say the absolute value of x is less than a, so let's think for a second. If I said the absolute value of x is less than 3, absolute value measures distance from 0. It's saying I want everything that is less than 3 from 0. So what numbers would work? 1 works, 2 works, and everything in between them, right? Can I do everything up until 3? Could I do like 2.9, 2.99? Isn't that still less than 3? Okay, so it's everything up here. If I go in the negative direction, I'm still measuring distance from 0. So we get everything between negative 3 and positive 3. So we could say x is everything between a negative and a positive a. Now this is the one thing that I think I set up a little bit different than Mrs. Keller. So when we do one of these problems, if you don't like my way, I'll do it her way. Okay, I don't want to confuse you. I like setting it up this way because this is a less than, did she used to say like less than and statement? And so it's bigger than this and less than this. Okay, you are going to get one interval of answers, everything between this number and this number. When it's great or, that's an or statement. We're actually going to get two separate pieces. If we think about that, if I said the absolute value of x is greater than 3. Okay, what that means, I want everything more than 3 away from 0. So if you're more than 3, then either has to be over here or over here. So we could say x is either greater than a or less than a negative a. And I'm pretty sure that when she did these, she wrote the two separate inequalities for both of them, and then you had to graph it at the end to figure out what your solution was. So this is just a difference in how I'm setting it up on my ands. I make one big one so I know my answer is just in between, and the or I do two separate ones so I realize my answer is two separate pieces. But if you guys don't like that way as we go through it, I can switch methods. Okay. All right, so those are the three pieces that we are going to look at today. Can we start some problems? Okay. We'll start with just some equations. If I say the absolute value of 2x plus 1 is equal to 7. All right. It is going to be important to kind of show some work here so you don't get confused. If it's an equal to, from what we wrote down, we make two separate equations. The first one, all we do is drop the absolute value. So 2x plus 1 equals 7. Or, for the other one, what do we do? So we make it a negative. And really all you have to do is one side of the equation. So I usually just go with the right, set one to positive 7 and one to negative 7. The rest of it stays the same. Now we just solve each of these. So if we subtract our 1, divide by 2, get positive 3. Is there a way to know if our answers are correct? Yeah, we can plug them into the original. If I put in a 3, I get the absolute value 7, which is 7. If I put in a 4, I get the absolute value negative 7, which is 7. For your answer, you can box both of these in, or we can write it, it is only those two numbers, so it's just a solution set. So you could put them in the solution set brackets. Either way is fine. Now, the key to this, the only reason we were able to go straight into the two separate inequalities is because the absolute value was by itself. If you do have anything with your absolute value, you have to isolate it first before we make our two separate pieces. So what would be the first step on this one? Absolute value of 4x plus 5 equals 5. And then we do our two equations. 4x plus 5 equals 5, or 4x plus 5 could equal a negative 5. Could be a positive or a negative inside that absolute value, because both are the same distance from 0. Okay, from here then we just solve. So if we subtract our 5, divide by 4, negative 10 divided by 4 is negative 5 halves. Again, you can box both of those in, or we could write it as a solution set. But make sure you isolate the absolute value first. And I want you guys to try one. value by itself. Subtract your 6 and divide by 2. So did you guys get the absolute value of x minus 4 equals 9? So that could mean x minus 4 is 9. Or x minus 4 could be a negative 9. If you add your 4 over, you get 13 and negative 5. And you could write those in a solution set if you wanted. What about this one? What's the first step? I get the absolute value of 3x plus 1 equals negative 15. Does anybody see a problem with that? It's negative. We said the absolute value is always positive. Can it equal a negative? No. So I don't even have to work it out. What's my answer going to be? No solution. If you didn't catch that and you went into making your two equations, you will get answers. But how do you check your answers? Plug them into the original, and when you plug them into the original, they would not work. But if you're paying attention, anytime you have an absolute value equal to a negative, we can just stop and say, no, this can't happen, because absolute values are always positive. All right. Questions about these equations? I'm going to put one, well, here, I'm just going to jump to this one. If I have an absolute value on both sides, that really doesn't change anything. Okay? If we know the two possibilities are these two things could be equal to each other, or they could be opposites, right? So my two equations, first one we just drop our absolute values, or if they are opposites, you have one equals the opposite of the other. Now you'll notice I put this negative out in front of my parentheses because when I do the opposite, you have to distribute that. We're going to make it a negative 2x and a positive 3. It would change both signs. So if it's more than one term, you have to take the negative to both. From here, we just solve our equations. Subtract over my 2x and my 6. And that equals negative 9. Divide, so x should equal positive 9. Or negative. Can I check these? Absolutely. If I put in 9, I get the absolute value of 15 equals the absolute value of 15. That works. If I put in negative 1, I get the absolute value of 5 equals the absolute value of negative 5, which works. So we can always check our answers on these equations. All right. Do we need more equations? Okay. Let's talk about the inequalities. These are the ones where we really need to remember our rules. And since our answer isn't just a single number, we are going to write these in interval notation at the end, which is the notation we've used for everything before now. Real quick, in interval notation, how do you know if you use a parenthesis or a bracket? If If it has an equal to, it gets a bracket. If it does not, everything gets a parenthesis. Okay, first question we have to ask ourselves. Make sure the absolute value is by itself, which it is. And then I have to ask myself, is this an and or an or? Or. Great or. So remember, if it's a less than, that's and. Greater than is or. So when we do an or, we make two separate inequalities. The first one, we just drop the absolute value. Or you drop the absolute value, but then for the negative, you flip your sign and make it a negative. So flip the inequality, make it a negative. Does everyone understand this step right here? You know why I wrote out two separate pieces and how I got both of those. So then we can solve these. We add our 4. When do you have to flip your inequality when you divide? Okay, if you divide by a negative. From here, I think Mrs. Keller always had you guys draw a graph, and you certainly can. If you don't need to, you don't have to. So when I say A is greater than or equal to 6, it's starting at 6. Would it be a parenthesis or a bracket? Bracket because of the equal to, and greater than would go to the right. When I say A is less than or equal to -2, that would be a bracket at -2, less than is going to the left. So do you see? We said or, and we get two separate pieces. That's what should happen on an or. So my answer, I want the interval for each of these. So we go left to right. So this is coming from negative infinity. Infinities always get a parenthesis, stops at -2, and that will get a bracket. Union. Next one starts at 6 and goes to infinity. When you have an or statement, your answer is going to look like this. It'll be negative infinity to a number, union, the number, to infinity. You're going to have two separate pieces. When we have an and, we're just going to have a starting and a stopping point because it's only one piece. It has to meet both requirements, so it's just in between two numbers. All right. Let's look at another one. On B, what is the first step? So we have the absolute value of 3b minus 1 is less than 6. We wait until our absolute value is by itself. Once it's by itself, then I'm going to look at this and say, okay, what does that tell me? And or? And. And so then we have to decide how we want to set this up. All right? So let me show you what I do, and if you don't like it, I'll go back to what you did last year. I know that if it's an and, I'm going to have a starting point and a stopping point, right? So I'm basically going to take this inequality. 3b minus 1 is less than 6. That's what I had. And then on the other side, we just put another less than and a negative 6. It has to be in between negative 6 and positive 6. So because it was an and, we can do them at the same time. It's a compound inequality. And we know it's just in between these two numbers. Then when you solve compound inequality, we still need to get b by itself, so we add 1. You just do it to both ends. So we have negative 5 is less than 3b is less than 7. Try and get b by itself, so divide by 3. So I have -5/3 is less than b is less than 7/3. When you go to turn that into an interval, it's really easy because this is where I start and this is where I stop. How do I know if it's parentheses or brackets? Right, no equal to, so parentheses. So it starts at -5/3, comma, ends at 7/3. So if we do the and as just one big inequality, when we get to the end, we don't have to necessarily draw a graph. I think what you did last year is you wrote 2 separate ones and then you had to graph them and look for the overlap where they both shaded. And we can certainly do it that way. This is just a little bit faster as long as we understand it. But if I confuse you there, I can do it a different way. What do you guys think? Are you okay with this method? Mm-hmm. So if it's an and, you can make one big one. If you don't like it, then you do it the other way. Okay, you make your 2 separate pieces just like we did with an or. And then if you need me to refresh your memory, I certainly can. I don't want to confuse anyone by showing too many methods in one day. But why don't you guys try this problem for me? Make sure when you decide if it's and or, it's not from your original. It's from the point when the absolute value is by itself. So what do you have to do first? Then divide by -5. If you divide by a negative, that flips the sign. Oops. So now it becomes a less than. And less than means and. Okay, so we know our answer should just be in between 2 numbers. I want to work this one out both ways because it looks like we're kind of split. Several people are still doing last year's method and several people are doing this year's, and either one is fine. If you want to do what I showed you this year, we say it's an and, so it's basically just creating one big inequality. We put the -19/5 and another less than on the left. And then we can solve. We subtract 2 from everything. And then we know our answer, it's just in between those. It was no equal to, so it's parentheses, -29/5 to 9/5. If you did it the other way, so if you understand what I just did, you can tune me out for a second. If you're doing it the other way, you have to realize this is an and in between. So this one, you flip it and make it a negative. So you get x is less than 9/5, and x is greater than -29/5. If you think about what this means on a number line, 9/5 is going this way, greater than -29/5 is going this way. Because it is and, you want the overlap, the part that got shaded by both of them. And so you get the same thing, the -29/5 to +9/5. And so you can take either option on those. Okay, how are we doing on these inequalities? Good. Do we need some more? No? Okay. Last thing I want to put up here. One slide. Every one of these problems can be solved with 0 calculation. I want to see if we can figure out what our answers would be. So A, the absolute value of 3x plus 5 equals -5. How do we know that? Yeah, absolute value cannot equal a negative. So if you see that, you don't even have to solve it. You can just say no solution. B. The absolute value is less than -5. An absolute value is is a positive number. Is a positive number ever smaller than a negative number? No. Okay, the last one, greater than. Absolute value is what kind of number? Positive. When is a positive number bigger than a negative number? Always. All real numbers are negative infinity, positive infinity. So if you have a negative, you really don't have to solve it, you just have to think about it. If it's a less than or an equal to, it's